today's class, what we are going to do is we are going to solve few problems based on the dependent motion and relative motion. So we have already read this problem yesterday. So what we are trying to do now is we are going to translate whatever is written in this problem in terms of mathematical equations. Are you with me, Shreya?
Yes.
Okay. So block B moves downwards with a constant velocity of 20 mm per second. So in this statement, there are two observations that we have to make. One, the block B is moving down at time t equal to 0 with a velocity of 20 mm per second downward, and at the same time, its acceleration is going to be 0 because it is moving with constant velocity. Do you agree with me?
Yes, sir.
Yeah, so I'm writing down this statement t equal to 0. Velocity of block B is minus 20 mm per second and its acceleration is 0. Happy?
Yes, sir.
Okay. And second statement now, the block A is moving upward with a constant acceleration. So block A is moving with constant acceleration. So I'm going to call it as AA, and that is constant. Do you agree with me?
Yes, sir.
Acceleration of block B is 0. However, acceleration of block A is constant. And what is the velocity of block A? So block A has a velocity of 30 mm per second. Are you with me?
Yes, sir.
And it is given as plus 30 mm per second. Nothing is moving upward is mentioned. So we assume that upward y is positive. Are you with me? And therefore
Yes.
we are going to call this as 30 mm per second. And mind you, this velocity of block A is at time t equal to 0 seconds. Are you with me?
Yes, sir.
So this is the data given about time t equal to 0 second. What else is given? Knowing that at time t equal to 3 second, slider block C has moved 57 mm towards right. This is what is given. Are you with me?
Yes, sir.
Now, so to write this in a mathematical calculation, what we are going to do is we are going to first define reference lines. Are you with me? So ऐसे कोई भी problem आप जब देखते हो तो इसमें आपको सबसे पहले क्या डिफाइन करना है? You have to define something called as reference line. Are you with me?
Yes, sir.
Okay. So what is the reference line? So you have to look at the motion of particles. Particles A and B, they are traveling in upward and downward direction. Do you agree with me?
Yes, sir.
Okay. So therefore, we need to measure distance of A and B with reference to a horizontal reference line. So अगर वो vertical plane में move हो रहा है, so we have to define horizontal reference line. Are you with me?
Yes, sir.
And uh, I have defined this as the reference line 1. Are you with me?
Yes, sir.
Okay. And I also need to define the perpendicular distance from this line when it is positive and when it is negative. Are you with me?
Yes, sir.
So I define an axis perpendicular to this reference line and I call that axis as y, and I treat y as positive when it is upward and y as negative when it is below the reference line 1. See?
Yes, sir.
Okay. Now, if you look at block C is going to exhibit motion along x direction or motion along the direction parallel to this reference line 1. Do you agree with me?
Yes, sir.
So I need to also define a perpendicular reference line to this motion so that I can capture the position of block C at given instant of time. Happy?
Yes, sir.
So I will have to define another reference line which is perpendicular to reference line 1, and the best choice would be I will consider this as reference line 2. Are you with me?
Yes, sir.
This is reference line 2. And with reference to this, if I am going to measure x towards right, I am going to call this axis as x, and towards right x is going to be positive. Happy?
Yes, sir.
I have defined the references. Reference हमने define किए, and then we have also defined naturally the origin. So where is the origin? Origin is somewhere here. Are you with me?
Yes, sir.
Okay. Now we will translate the next data, knowing that at time t equal to 3 seconds. So I have written time t equal to 3 seconds. block C has moved 57 mm towards right. So this block has moved 57 mm towards right from this position. So therefore XA equal to 57 mm at time t equal to 3 seconds. Do you agree with me?
Yes, sir.
And one more data we need to add at time t equal to 0, XA is 0. Because we have chosen this as reference line 2. Happy?
Yes, sir.
Okay. So what is XA? XA is the distance of this face of block C with reference to this reference line 2. Happy?
Yes, sir.
Okay. Now, जैसे now what I am going to do is I am going to define coordinates. So distance of C, block C from this space, I am going to call it as XA, XC. I'm sorry, we have called it as XA, but it needs to be called as XC because block C is moving. Are you with me?
Yes, sir.
Similarly, I will call this as XC. XC. So what is XC? XC at given instant of time is nothing but the position of, let us say, position of left hand side face of block C from this reference line 2. Do you agree with me?
Yes, sir.
Okay. Now I am going to define something called as YA. What is YA? YA is a distance of centroid of block A. Whether you consider centroid, whether you consider upper face, whether you consider lower face, it's all right because we are idealizing everything as a particle. Block A is a particle, block B is a particle, block C is also a particle. Are you with me?
Yes, sir.
So therefore, this distance from this perpendicular distance from reference line 1, I am going to call it as YA. And the distance of perpendicular distance of centroid of block B with reference to the reference line 1, I am going to call it as YB. Are you with me?
Yes, sir.
Is it necessary that YA should be always equal to YB? No. If block A moves up, block B will go down and YA will not be equal to YB in general. Do you agree with me?
Yes, sir.
Now, so here, this is the first problem, we are not going only into the steps of the problem. I am trying to explain you the concepts involved. So therefore, solution is quite simple, but we have to understand what we are doing. So this YA, YB, and XC, are they constants with reference to time, or are they going to vary with reference to time?
Sir, can you repeat?
These three values, YA, YB, and XC, are they going to be constant throughout the motion, or are they going to change as the time
They are
evolves?
going to change.
Yes. So do you agree with me that these all are functions of time?
Yes, sir.
Functions of,
Sir, can you just give me 1 second?
yeah, sure. So meanwhile, I will ask Kanishk to unmute. Kanishk, are you there?
Yes, sir.
Yeah. So let us go ahead. So YA, YB, and XC are functions of time. Do you agree with me?
Yes, sir.
And they also talk about position of block A, B, and C. Do you agree with me?
Yes, sir.
Position of blocks A, B, and C at given instant or at given t. Do you agree with me?
Yes, sir.
Okay. Now, having said that, so can I call them as position coordinates? Yes.
Yes, sir.
So therefore, I am going to call all these three as position coordinates. Are you with me?
Yes, sir.
Coordinates. Fine. Now, look at this problem and tell me which is one thing related to YA, YB, and XC which is independent of time. YA, YB और XC ये तो time पे dependent है. लेकिन what is one thing that you can look into the physics of problem and tell me one thing which is related to YA, YB, and XC which is independent of time? Can you tell me that? Yes, Kanish.
So will it be the mass of A, B, and C?
Yeah, but it is not connected to YA, YB, XC. I said something connected to YA, YB, and XC, which is independent of time.
So will it be the length of the wire?
Yes, precisely. I'm very happy that you answered this. So now, how many wires are there? Or how many lengths? How many cables are there? Only one?
Yes, sir.
Do you agree? So we have one quantity which is related to YA, YB and XC, and that is length of this one cable. Do you agree with me?
Yes, sir.
So I will write length of cable is constant. It is not changing with reference to time. And that constant, I am going to call it as C. Are you with me?
Yes, sir.
Okay. Now, can we write down this length of cable in terms of YA, YB and YC? Easily. कैसे लिखना है? जरा देखो. I will try to write this. Okay. Yes. Can you tell me how much is this length in terms of YA? Will it be YA minus this distance?
Yes, sir.
Are you with me? तो इसको मैं बोल and do you agree that as the block moves up or down, this distance is not going to change?
No, sir, it won't change.
It won't change. So can I call it as C1?
Yes, sir.
Yes. So what is the length of this cable which is marked in black? So I am now going to follow a color code. So black में जो length मैंने mark की है, उसकी length जरा बताओ क्या है? So is it YA minus C1?
Yes, sir.
Okay. So we have got now this length. Now what can you say about this length of the cable? Is it going to be constant or is it going to change as the blocks move?
Constant, sir.
This is also constant. So can I call this as another constant C2?
Yes, sir.
Okay. And then I'm going to add in that plus C2. Happy?
Yes, sir.
Okay. Now, what can you say about the length that now I'm going to mark in red? यहाँ से लेके यहाँ तक. How much is this length?
So, C2 plus YA plus C1.
So therefore, I will have to define this constant, this length. Do you agree with me?
Yes, sir.
Can I call this as C3?
Yes, sir.
Yes. So what will be this length? Red one, YA minus C1 plus C3. Do you agree with me?
Yes, sir.
And C1 plus C3 are constant. These lengths are not going to change with reference to time as block A moves up and down. Are you able to imagine that?
Yes, sir.
Okay. So can I write this as देखो, plus I am following a color code so that you understand it later. So YA minus C1 plus C3. Agreed?
Yes, sir.
Okay. Now, what can you say about this length? It is precisely the same.
Yes, sir.
Do you agree with me?
Yes, sir.
So therefore, I am marking it in red. So total summation of these two red lengths will be equal to twice of this. Agreed?
Yes, sir.
Twice. Okay, fine. Now, what can you say about this length? It is constant.
Yes, sir.
Can I call it as C4?
Yes, sir.
Yes. So plus C4. Happy?
Yes, sir.
Okay. What can you say about this length? Constant.
Yes, sir.
Can I call it as C5?
Yes, sir.
So plus C5. चलो आगे चलते हैं. Now what can you say about this length? How much is this? Yeah, tell me.
So will be same as the previous ones we calculated.
No. Now YB comes into the picture. Are you with me?
Yes, sir.
This will be now YB minus this distance. This distance. Do you agree with me?
Yes, sir.
And how much is that? Tell me.
So YB minus the distance, sir. C6.
So can I call it as C6?
Yes, sir.
This distance is constant. So I will call it as C6. So what is it? YB plus yb, bolo, minus
minus C6.
c6. And what can you say about this length, this length, and this length? All of them are same.
Yes, sir.
Are you with me? So how many times? 1, 2, 3, 4. Do you agree with me?
Yes, sir.
So can I call it as 4 times yb minus c6?
Yes, sir.
Okay. What can you say about these lengths? Chalo. This one and this one. Constants?
Yes, sir.
So can I name them as C7 and C8?
Yes, sir.
C7, C8. So plus C7 plus C8. Happy?
Yes, sir.
Okay. Now, what can you say about this length? Constant?
Yes, sir.
कहाँ से कहाँ तक? यहाँ से यहाँ तक. Just a second. What
So,
can you say about this length?
yes, sir. This part will be constant, but the part outside the push should not be constant, sir. It will change as C varies, right, sir?
Yes, but wait a minute for that. So this length is constant. Do you agree with me?
Yes, sir.
And I have placed this reference line at this constant distance from this end. So this length also is going to remain constant. Do you agree with me? What is going to change is the next part of the length, which is xc. Happy?
Yes, sir.
Are you with me?
Yes, sir.
So ये जो लेंथ है, क्या मैं इसको C9 बोल सकता हूँ?
Yes, sir.
Plus C9. And now here xc is 0, xc is not seen, but I will have to add it, and I am going to add that xc in this. Do you agree with me?
Yes, sir.
Plus xc. अब जरा देखो, you may ask, what if the block C moves towards left? Okay, xc will be negative, so it will be C9 minus xc. It will be taken care of. Are you with me?
Yes, sir.
So whether xc is 0, less than 0, or greater than 0, the sign of xc will make this equation correct. Do you agree with me?
Yes, sir.
Okay. Now, what can you say about all this sum? This sum needs to be constant. Happy?
Yes, sir.
And what do we call that constant as? We have called that constant as C. अब एक काम करेंगे, इसमें से सिर्फ ऐसे टर्म्स हम लेफ्ट हैंड साइड में रखेंगे जो टाइम के फंक्शन है, और बाकी सारी चीजें जो कांस्टेंट्स है उसको हम राइट हैंड साइड में लेके जाएंगे. Are you with me?
Yes, sir.
So that gives me what? Ya. Happy?
Yes, sir.
Plus 2 times ya. Agreed?
Yes, sir.
Plus 4 times yb plus xc. Agreed?
Yes, sir.
These are the terms which depend upon time. So I have considered these terms. Happy?
Yes, sir.
Now we have to consider constant terms, and we have to take those constant terms on right hand side. So this minus c1 goes on right hand side, becomes plus c1. Happy?
Yes, sir.
This plus c2 goes on other side, becomes minus c2. What happens to this 2 times c1 plus c3? It is negative here. On other side, it goes and becomes positive. Agreed?
Yes, sir.
What happens to this c4? Negative. What happens to this c5? Goes on the other side, becomes negative. What happens to this 4 times c6? Here it is negative. On other side, it goes and become positive. Agreed?
Yes, sir.
What happens to c7, c8 and c9? Minus c7, minus c8 and minus c9. Are you with me?
Yes, sir.
Now, is this entire thing a new constant?
Yes, sir.
So can I replace this by a single constant, which I will name it as c10? Happy?
Yes, sir.
So what is the equation that we finally get? We get the equation that ya 3ya plus 4yb, are you with me,
Yes, sir.
plus xc. This needs to be constant. Therefore, we call this motion as dependent motion. You can give me independently the values of any two of these coordinates. The value of third coordinate will be decided using this relation. Do you agree with me?
Yes, sir.
So therefore, this motion is called as dependent motion. Now just carefully observe the equation that we have written. ये equation हमने किसके terms में लिखा है? Have we written down this equation in terms of position coordinates?
Yes, sir.
Okay, so we have written this equation in terms of position coordinates is the first observation. Second observation, does it involve mass or force?
No, sir.
So it doesn't involve mass, force, moment of a force or moment of inertia. ये कुछ भी नहीं है. Are you with me?
Yes, sir.
हाँ, so जिस प्रॉब्लम में ये कुछ भी नहीं रहता उसको हम क्या बोलते हैं, काइनेटिक्स या काइनेमैटिक्स?
Kinematics, sir.
हाँ, so is it the relationship written in kinematics? Are you with me?
Yes, sir.
तो इसीलिए इस रिलेशन को हम बोलते हैं KRBPC. KRBPC. I am going to tell you its long form. This is not a standard short form. This is what we will be using it. This is kinematic kinematic relationship between position coordinates. Are you with me?
Yes.
Position coordinates. Now, tell me, how many KRBPCs can we write? Only one, because here there is only one string. Do you agree with me?
Yes, sir.
So in general, in a problem, if you have two cables जिसका length change नहीं होने वाला है, we can write two KRBPCs. Do you agree with me?
Yes, sir.
So जितने number of cables रहेंगे, उतने KRBPCs रहेंगे. ये याद रखना. Are you with me?
Okay, sir.
So how many KRBPCs?
One, sir.
Number of cables है. Number of inextensible cables. Happy?
Yes, sir.
जितने इनएक्सटेंसिबल केबल्स है उतने KRBPCs हम लिख सकते हैं. In this particular case, we are going to write down only one KRBPC. Happy?
Yes, sir.
Okay. Now, what if I differentiate this KRBPC? What do I get? Differentiate with reference to time. So I am going to call this equation as 1. Are you with me?
Yes, sir.
And let me differentiate it with reference to time. So take derivative with respect to time. And whenever we take a differentiation of a quantity with reference to time, we denote it by dot. Are you with me?
Yes, sir.
If we take the derivative with reference to space, we denote it by dash. But otherwise, we denote it by dot. So, differentiation of YA, can I write it as 3YA dot? Are you with me?
Yes, sir.
Plus 4YB dot plus XC dot. And what will be the right hand side? Differentiation of a constant with reference to time is 0. Do you agree with me?
Yes, sir.
Now, what is YA dash? YA dash is differentiation of position of block A with reference to time. So, can I call it as velocity?
Yes, sir.
So, therefore, what is the expression that we get? 3 times velocity of block A plus 4 times velocity of block B plus 1 times velocity of block C. This must be equal to 0. Are you with me?
Yes, sir.
1 minute. हॅलो. हा सर, लेक्चर चालू आहे, नंतर कॉल करतो. Are you with me?
Yes, sir.
Now, if we differentiate this, I will call this equation as 2. If I differentiate this equation once more, what do I get? 3 times acceleration of block A plus 4 times acceleration of block B plus acceleration of block C must be equal to 0. Happy?
Yes, sir.
And this is equation number 3. Now, what is the sign convention for velocities and accelerations? So, if it is a vertical velocity, that means if it is associated with A and B, then A and B. If it is associated with A and B, then upward velocity or acceleration is positive and downward velocity and acceleration is negative. Same is true for position coordinates. Are you with me?
Yes, sir.
Now, if it is associated with block C, then position coordinate is x and its velocity and its acceleration for block C, it will be positive if it is towards right and it will be negative if it is towards left. Agreed?
Yes, sir.
Now, uh, so this is the equation that we have, these are the three equations that we have written based on the KRBPC. Are you with me?
Yes, sir.
Okay. Now what else is, now we will try to look at the question. So question में क्या पूछा है? The velocity of slider block C. So we have to decide the velocity of slider block C at time t equal to 0. Are you with me?
Yes, sir.
What is the information that we have at time t equal to 0? At time t equal to 0, we have velocity of block A and velocity of block B. Are you with me?
Yes, sir.
So अब मैं लिखता हूँ यहाँ पे at time t equal to 0, what is the velocity of block A? Velocity of block A is minus 20 mm, sorry, velocity of block A is 30 mm per second and velocity of block B is minus 20 mm per second. Are you with me?
Yes, sir.
30 mm per second. Velocity of block B is equal to minus 20 mm per second. Happy?
Yes, sir.
Now, what is the equation that we are going to use to get velocity of block C at time t equal to 0? These equations are valid at all instances of time.
Yes, sir.
Therefore, we are going to consider the second equation. So, what is the second equation? 3VA plus 4VB plus 4VC equal to plus VC equal to 0. This is the equation that we are going to use. Are you with me?
Yes, sir.
In that, how much is VA? VA is 30. How much is VB? VB is minus 20. So what do we get? 33s are 90. 90 minus 80. So we get 10 plus VC equal to 0. Agreed?
Yes, sir.
And how much is VC now? Tell me.
Minus 10, sir.
Minus 10 mm per second. Happy?
Yes, sir.
When at time t equal to 0. And what does it indicate? As the sign is negative, therefore block C at time t equal to 0 must be moving towards left. Are you with me?
Yes, sir.
Okay, so we have found out the magnitude as well as direction of velocity of block C at time t equal to 0. We have answered the first question. Are you with me?
Yes, sir.
Now, accelerations of block A and C. ब्लॉक ए और सी के एक्सेलरेशन कितने हैं वो पूछा है. सो ब्लॉक ए बी का ब्लॉक बी का एक्सेलरेशन तो 0 दिया है. आर यू विद मी?
Yes, sir.
एंड देन ब्लॉक ए का एक्सेलरेशन कांस्टेंट है ऐसे दिया है. आर यू विद मी? सो
Yes, sir.
कितना है वो नहीं दिया है. आर यू विद मी?
Yes, sir.
So now what is the equation that we are going to use for this second part?
Third equation, sir.
So this was the first part. We are going to use this equation for the second part. Are you with me?
Yes, sir.
लेकिन इसमें से दिक्कत ये है that you have been given the acceleration of block B, but you have not been given acceleration of block A and C. Are you with me?
Yes, sir.
This results only in one equation. What is that equation? For what is acceleration of block B? It is given as 0.
Yes.
So 3AC plus AC equal to 0 is what we get. Are you with me?
Yes, sir.
Because AB is given to be 0 in the problem. और एक और चीज दी है, क्या दी है? A is constant. That means acceleration of block A is not a function of time. Are you with me?
Yes, sir.
Not a function of time. If it is so, do you acknowledge that AC also has to be constant? Because if this equation has to be satisfied, if A is not a function of time, AC will naturally will not be a function of time.
Yes, sir.
Therefore, AC is also constant. That's what we understand. Are you with me? But we
Yes.
have to compute value of this constant accelerations AA and AC. How do we do that? So for that, we have been given a data. What is the data that is given? At time t equal to 3 seconds, the slider block C has moved by 57 mm. Are you with me?
Yes, sir.
Now, let us look at block C now. What kind of motion does it perform? It is going to perform a uniformly accelerated motion. Do you agree with me?
Yes, sir.
Why uniformly accelerated motion? Because I proved that AC is constant. Happy?
Yes, sir.
This uniformly accelerated motion from time t equal to 0 to 3 seconds has resulted in XC being equal to plus 57 mm. Do you agree with me?
Yes, sir.
Plus 57 mm. Now, if that is so, what is the relationship between X, A and T for uniformly accelerated motion? Can we use the formula S is equal to ut plus half at square?
Yes, sir.
Are you with me? So let us
Yes.
translate this formula in our notation here. What is S here? Xc. Happy?
Yes, sir.
This is equal to, what is U here? It is velocity of block C at time t equal to 0. Initial velocity. Are you with me?
Yes, sir.
Into T. T is 3 seconds, because in 3 seconds the block has moved by 57 mm. So Xc is 57. Plus, what is A? A is nothing but constant acceleration of block. So I will call it as AC. Are you with me?
Yes, sir.
Into 3 square. Now, do we know velocity of block C at time t equal to 0?
Yes, sir.
Yes. We just now calculated. What is the velocity? Tell me. Where is it? Minus 10.
Yes, sir.
So can I substitute this value as minus 10? Yeah.
Yes, sir.
So what is the equation that I get? 57 must be equal to minus 10 into 3 plus half acceleration of block C into 3 square. Simplify and tell me the value of AC. Are you with me?
Yes, sir.
So this becomes 30. It goes on other side. It becomes 87. So 87 into 2 by 9.
So 19.33.
Yeah. So it turns out to be
33.
19.33. Yeah, possibly correct. And it has turned out to be positive or negative. It is positive.
Positive, sir.
Therefore, the block is accelerated towards right. Are you with me?
Yes, sir.
So we have found out the value of acceleration C. Now what are we going to do? We are going to use this equation to get acceleration of block A. Are you with me?
Yes, sir.
So what do we get? 3AA plus 19.33 must be equal to 0. So what is the value of AA? Tell me.
So minus 6.44.
Minus 6.44. What is the unit? Here
Millimeter.
also we did not write unit. Mm
Millimeter
per
second
second
square.
square. Are you with me?
Yes, sir.
Mm per second square. Velocity also we have to write down the unit. Hopefully we have written. Yes. Chalo. What is the indication of what is the meaning of negative sign? Negative sign indicates for block A that the block is accelerating downwards. Block is accelerating downwards. Is that right?
Yes, sir.
Let me check 1 minute. Just a second. Yeah. So therefore, this acceleration is in downward direction. Happy?
Yes, sir.
Okay. So we have found out, we have answered the second part. Agreed?
Yes, sir.
Change in position of block A after 5 seconds is what is being asked. Are you with me?
Yes, sir.
Uh, just give me a second.
Yes, sir.
मैंने क्या कैलकुलेट किया लास्ट में एक्सेलरेशन ऑफ ब्लॉक ए
And C, sir.
हाँ that is being calculated हाँ and we need to it is moving with upward with velocity 30 mm per second. Okay, and block B was moving with, okay, fine. Now third, we need to find out the change in position of block A after 5 seconds. Happy?
Yes, sir.
What is the position of block A at time t equal to 0? Yeah, tell me.
Um,
So
so so
at time t equal to 0, is its position ya?
Yes, sir.
Are you with me?
Yes, sir.
Okay. Now, let us try to write down. Let us try to analyze what kind of motion block A is exhibiting. As it is a constant acceleration, therefore block A is experiencing a uniformly accelerated motion. Do you agree with me?
Yes, sir.
So we can use the formula for uniformly accelerated motion. और कितने seconds के बाद पूछा है हमें? We have been asked
5 seconds, sir.
after 5 seconds. Do you agree with me?
Yes, sir.
Just give me a second. Let me clear the board. We have to take this to right. So remaining part we will start solving from here. Now, so at time t equal to 0, I am going to write down the position of block A is ya. Do you agree with me?
Yes, sir.
This is the position. At time t equal to 5 seconds, let us say y5 ya at 5 is its position. Are you with me?
Yes, sir.
Now, so I'm going to call this position as ya at time t equal to 0. Now, as it is exhibiting uniformly accelerated motion, I should write s is equal to ut plus half at square. Do you agree with me?
Yes, sir.
However, you have to understand that this s is change in position and it is not the position at time t. Are you with me?
Yes, sir.
Change in position from time 0 to t. Are you with me?
Yes, sir.
So in fact, you have to understand that it is position of block A at time t minus position of block A at time 0. Are you with me?
Yes, sir.
However, in most of the cases, as this value turns out to be 0, therefore we always interpret this as position of block A at time t. However, that is not always true. Like in this case, the block did not start with 0 position. Are you with me?
Yes, sir.
So we are going to now convert this equation into the nomenclature that we are using. So what is position of block, change in position of block A in 5 seconds? It is ya5 minus ya0. Are you with me?
Yes, sir.
This is what is asked. Change in position ही पूछा है. You have not been asked the position of block after 5 seconds. You have been asked change in position. Are you with me?
Yes, sir.
This is equal to, yeah, tell me what it is. Ut, that means velocity of block A at time t equal to 0. Happy?
Yes, sir.
Into t. T is 5 seconds. Ut plus half acceleration of block A. It is constant multiplied by 5 square. Happy?
Yes, sir.
And that is how much. What is the velocity of block A at the start? 30
So
mm per
30
second.
meters per second.
Yeah. So 30 into 5 What is the acceleration of block A? Just now we have evaluated.
Minus
It is minus
6.44.
6.44. So I will substitute that minus half 6.44 into 5 square. So can you tell me what is change in position?
Sir, 69.5, sir.
Plus or minus?
Plus.
Are you sure it is plus?
Yes, sir.
No. Okay, half है, सही है. Plus होगा. कितना हुआ?
69.5, sir.
69.5 mm.
Meter.
Excuse me. And this has turned out to be positive. That means the block A has moved up during 5 seconds. Do you agree?
Yes, sir.
So after the 5 seconds जो भी 0 टाइम पे पोजीशन था उससे ये ऊपर गया है because change in position is positive. Are you with me? No. Yeah, change in position is positive. Are you with me?
Yes, sir.
Okay. So we have answered the third question as well. Third part as well. And now let us try to answer the question that we have raised. Relative velocity of D with reference to A and B. Are you with me?
Yes, sir.
When? So I will have to specify some time here. So let me specify at time 5 seconds. T equal to 5 seconds. Are you with me?
Yes, sir.
तो अब इसके लिए मुझे क्या करना पड़ेगा? आई एम गोइंग टू सॉल्व वन पार्ट ऑफ इट, अनदर पार्ट यू आर गोइंग टू सॉल्व. आई एम गोइंग टू नाउ कंप्यूट relative velocity of D with reference to A. Are you with me?
Yes, sir.
So if I have to do that, what I am going to do is I am going to give a cut to this string at D. So we are going to now solve the last part where we have to find out what do we have to find out? Velocity of D with reference to A at t equal to 5 seconds. Happy?
Yes, sir.
Great. As this is what we are seeking, therefore I am going to give cut to this string at D. Are you with me?
Yes, sir.
Cut at D. And I am going to consider that part of the string where A lies. Are you with me?
Yes, sir.
Because we have to calculate velocity of D with reference to A. So consider that part of string where A lies. Are you with me?
Yes, sir.
Okay. So when you are calculating velocity of D with reference to B, you will consider which part? Naturally, you will consider the right part. Are you with me?
Yes, sir.
Okay. So ab, tell me, as this point D on the string moves up and down, however, the length of this much portion of the string has to remain constant. Do you agree with me?
Yes, sir.
ये जो लेंथ है, ये तो कांस्टेंट रहना चाहिए कि नहीं रहना चाहिए?
Yes, sir.
This has to be constant. So the
Yes.
length which I have marked in black color must be constant. Do you agree with me?
Yes, sir.
Okay. अब हम ये इक्वेशन फिर से लिखेंगे something similar to KRBPC, but it is written only for a part of this string. Are you with me?
Yes, sir.
हाँ, तो कैसे लिखेंगे? चलो, now we are going to define something new. Position of this point D on the string at given instant of time, I am going to call it as YD. Are you with me?
Yes, sir.
This is YA. So now, can you write down this portion in terms of YA? Yes, it is going to be YA minus some constant length. So I will forget about that constant length. I will simply write it as YA. Do you agree with me?
Yes, sir.
Then this is a constant portion, forget about it. Then I have again YA, I have again YA. So I will write this as YA plus 2 times YA. Agreed?
Yes, sir.
Forget those constant portion because anyway they go on the right hand side and become another constant. So forget about those. Now, what can you write about this length? It is yd.
Yes, sir.
This must be equal to constant. So what is the equation that we have got which involves now position of point D? 3ya plus yd equal to constant. Happy?
Yes, sir.
Now, can I differentiate this equation? Yes, I will get 3va plus vd equal to constant, equal to 0. Happy?
Yes, sir.
Okay. At time t equal to 5 seconds. At time t equal to 5 seconds. What is the velocity of block A? Below. The velocity of block A at time t equal to 5 seconds is equal to velocity of block A at time t equal to 0 seconds plus acceleration of block A multiplied by 5. V is equal to u plus at. Agreed?
Yes, sir.
Why can we apply this equation? Because block A is exhibiting uniformly accelerated motion. Is that right?
Yes, sir.
Block A is exhibiting uniformly accelerated motion. Therefore, we can use that formula. Are you with me?
Yes, sir.
So I will write that. This formula can be used only in case of uniformly accelerated motion. Are you with me?
Yes, sir.
And as block A is exhibiting that, therefore I can write that formula. So now can you tell me velocity of block A at 5 seconds?
So minus 2.2 millimeter per second.
So tell me the values. What was this? 30 mm per second.
Yes, sir.
Plus
Plus minus
6.44
6.4 into
into
5.
5. Yeah. So how much is that?
Minus 2.2 millimeter per second, sir.
Minus 2.2 millimeter per second. So this velocity must be in therefore downward direction. Agreed?
Yes, sir.
Okay. This is what I have written. Now, can we find out velocity of d at 5 seconds? Yes, because 3 times velocity a at 5 seconds must be equal to plus velocity of d at 5 seconds must be equal to 0. Happy?
Yes, sir.
So what is 3 times minus 2.2?
So minus 6.6. VD becomes plus 6.6, sir.
So velocity of d at time t equal to 5 seconds becomes equal to, yeah, tell me,
6.6, sir. 6.6 meters.
6.6 mm per second.
Sorry.
And as it is positive, therefore it is upward. Happy?
Yes, sir.
Now, so we have got both the velocities. Now, relative velocity of d with reference to a at time t equal to 5 seconds is what? It is velocity of d at time t equal to 5 seconds minus velocity of a at time t equal to 5 seconds. This we have proved in the last class. Are you with me?
Yes, sir.
Okay. So how much is that? Tell me.
So 8.8 millimeter per second, sir.
With sign you have to substitute. I hope you have substituted it with sign.
Yes, sir.
6.6 minus
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 2.2.
2.2. So how much is it? It is
8.8, sir.
8.8 mm
Millimeter per second.
per second. What is the meaning of positive sign? That means block A is moving upwards with reference to block D, therefore positive sign. Are you with me?
Yes, sir.
So block, what is the interpretation of positive sign? Block D is moving up with reference to block A. It is not necessary that in absolute sense block D will be moving upward. No, with reference to block A, it is moving upward. Are you with me?
Yes, sir.
In this particular case, even in absolute sense, block D is moving up, but it is absolutely not necessary. Are you with me?
Yes, sir.
Okay. So have we answered the question? Last one. Yes, partially. The second part you have to do as a homework. तो आपको क्या करना है अभी second part में? You have to find out velocity of
Still
block D
expected.
with
Yes, sir.
reference to B at 5 seconds. तो आंसर तो आपको मिल जाएगा यहाँ पे ही, what is velocity of block B at time t equal to 5 seconds? जरा बताओ मुझे.
So velocity of block at t is equal to 0 seconds plus acceleration into 5, which is
Correct.
time, sir.
So, oh, what has happened? 1 minute. Okay. So it is velocity of B at time t equal to 0 seconds. बोलो plus
Plus acceleration into time.
ut plus u plus at. Are you with me?
Yes, sir.
So acceleration of block B into 5. So can you tell me this? What is velocity of block B?
Minus 30, sir.
No, minus 20 it was, if I'm right.
Minus 20, right, sir. Sorry, my bad. Minus 20, sir.
Minus 20. So I will substitute that as minus 20 here. Plus, what is acceleration of block B? Did we compute acceleration of block B?
Yes, sir. 19 point.
No, block B had zero acceleration.
Zero acceleration, sir.
Are you with me?
Yes, sir.
So here, if I substitute this as 0, that means naturally velocity of block B after at 5 seconds is also going to be minus 20 mm per second. Happy?
Yes, sir.
Now, what is velocity of block D with reference to velocity of block B at time t equal to 5 seconds? It is Vd5 minus Vb5. So it is equal to 6.6 minus of minus 20. Agreed?
Yes, sir.
So it is how much?
20.66, sir. 26.6, sir.
6 mm per second. And positive आया तो इसका मतलब क्या है? Block B is moving up with reference to block B. Are you with me?
Yes, sir.
Moving up with reference to block B. तो ऐसे भी किया जा सकता है. This is the easier way of solving this problem. However, I encourage you to solve this problem by writing the equation for next part of the string in terms of YD. Are you with me?
Yes, sir.
So then also you should get the same answer. I will encourage you to do that. So what is the trick? जहां का velocity आपको पूछा है वहां तक string को cut करो. Write down the KRBPC for either left hand side part or right hand side. Are you with me?
Yes, sir.
And then answer whatever question that is being asked. Have you understood this?
Yes, sir. Understood.
Okay, so this is the problem on dependent motion. Now quickly you are going to run through, you are going to read the second problem. You will try it at your home, but we will have its solution in the next class. Okay. Kanish, are you with me?
Yes, sir.
Yeah. So can you read the statement?
Yes, sir. The system shown starts from rest and each component moves with a constant acceleration. If the relative acceleration of block C with respect to collar B is 60 millimeters per second square upward and the relative acceleration of block D with respect to block A is 110 millimeters per second square downward, determine the velocity of block C after 3 seconds and the change in position of block D after 5 seconds.
Okay. So थोड़ा सा elevated problem है because data is given in terms of relative acceleration. So you are encouraged to solve this, but even if you don't get it right, it's all right. We are going to solve it in tomorrow's class. Are you with me?
Yes, sir.
However, in meanwhile, tell me how many strings are there in this problem? How many strings are there?
So it's 2 strings, sir.
Yes. So therefore, how many KRB PCs are going to be there?
2 KRBPC, sir.
Right. So we will write down these KRB PCs and we will stop for today. Okay.
Yes, sir.
All the blocks, everything is moving in vertical direction. So I need only one reference line. This becomes my reference line. Are you with me?
Yes, sir.
And this Y is going to be positive. Okay.
Yes, sir.
This is the position of block A, YA. This is the position of block D. I'm going to call it as YD. These are functions of time. Are you with me?
Yes, sir.
Then this is the position of block C. I'm going to call it as YC. And the position of block B, I'm going to denote it by notation YB. Are you with me?
Yes, sir.
Chalo, quickly now. Tell me the length of first string. So this length is going to be YA minus some constant. So I will take it as YA. Are you with me?
Yes, sir.
Now, can you tell me how much will be this distance? This length?
So
It will
YB
be
minus
YB
constant,
minus
sir.
YA.
Yes, sir.
So can I write this as YB minus YA
Yes, sir.
plus some constant? Forget about that. So I have written this length YB minus Y. What can you say about this length?
So same, sir. YB minus YA.
No, there is no.
So just YA, sir.
No. Just a second. I was talking about this length. This is 2 times YA. Then we are talking about this length. No, why will it be YB minus Y? I'm sorry. This length will be YB itself. Do you agree?
Yes.
And then this length is also YB. So I'm going to have 2 times YB. Agreed?
Yes, sir.
This length is constant. And what is this length? Plus YC. Happy?
Yes, sir.
This must be equal to constant. This is the first KRBPC. Now let us write down the length of second cable. That is interesting. Now, how much is this length now? YD minus YA.
Yes, sir.
Dekho, YD minus YA. And then some constant, forget about that. How much is this length? It is YD minus YB.
Yes, sir.
So this plus this must be constant. Happy?
Yes, sir.
So we have now written down 2 KRB pieces corresponding to 2 strings, and now we will solve the remaining problem in next class. Okay?
Yes, sir.
Okay. You are encouraged to solve it at your home. You can take a screenshot if you want. Take a screenshot of this problem. Just a second. Okay. Now take a screenshot of problem number 33. Have you taken?
Yes, sir.
Okay. You can share it on our group. Everyone is encouraged to solve this problem at home. However, I will be going through the detailed solution in next class. Let us stop here. If anyone has any doubt, please ask me.